Good morning, student. Today, the second basic concept of electricity, current electricity chapter, and the main topic discussed will be the Ohm's law, its proof. Student, yesterday already we have discussed the concept of drift velocity. Are you remember? Have you revised it? Remember, student, revision means analyzing it without seeing the book, without seeing the notes. You should analyze. So, do you remember what is drift velocity? I am just making you remind again. Electrons charge carriers have two kinds of velocities. One is thermal velocities, which is very fast. They are moving randomly. And as already I have said, that is not giving rise to any current. The second is drift velocity, student. Drift, D-R-I-F-T. It is the velocity acquired by the electron due to the electric field. And this velocity is very less. And why it is drift? Because electrons are forced to move in a particular direction. So the velocity is known as drift velocity. Remember, student, this is the velocity which is giving rise to electric current because charge has energy and it is flowing in a particular direction. So today our lecture will flow in this direction as you can see in the screen. First I will discuss about the term mobility in detail. Then I will discuss about the Ohm's law statement. And remember, student, Ohm's law does not mean only V is proportional to I as you have studied in 10th class. We have to very go in minute detail of it and the proof of it, student. So let's start with the term mobility. Okay, student. Now see, whenever across a conductor we apply electric field, and as already you know, electric field is applied by the help of a cell, by the help of a battery. Every cell or a battery has a EMF. Student, EMF is a very important term. I will take it a separate class to convey the meaning of EMF. Okay, now you understand that it applies potential difference across a conductor. It forces the charge carriers to flow. That is the source of current actually. Now we have applied electric fields. As I have said, in case of conductors, electrons will be forced to move in a particular direction and the average velocity acquired is drift velocity. So suppose I will take one sample, say I am taking aluminium and I am applying unit electric field. Say unit, I am applying certain electric field and it acquires certain velocity. Then for unit electric field, how much is the drift velocity acquired per unit electric field? That is student mobility. That is mobility, student. So remember, mobility is defined for a charge carrier, student, and charge carriers are of two kinds. Already you know, positive and negative. Negative charge carriers are electrons and positive charge carriers are also known as holes. We will do it in detail in semiconductor. Holes means it is a vacancy where the electron has left that atom. That vacancy is known as holes, electrons. Sorry, that vacancy is known as holes, okay, where the electron have left it. So student, the mobility, as you can see in the screen, I have written the formula. Mobility, the mathematical formula is Vd upon E. Now how will you define it, student? It is the drift velocity developed when electric field applied is unity. Student, imagine in your mind, you are taking a sample and unit electric field has been applied. So how much is the drift velocity of the charge carriers? That velocity is mobility, student. Now as you student, now it's unit. So as you know, velocity meter per second. See on the screen, I have written it. Electric field, 1 unit is volt per meter. On that basis, 1 unit is meter square per second per volt. You can write electric field in terms of Newton per coulomb also. On that basis, another unit we have meter coulomb per second per Newton. Now student, dimensional formula. See, I have formulated how it is determined. Dimensional formula. See, first I have written L. Can you see in the screen? So student, that L is for length. Then I have written ampere. A stands for ampere and T for time. That is for coulomb. See how I am taking it. First word is meter. In the above you see in the screen. For meter I have written L. Then I have coulomb. For coulomb I have written ampere into time. Then S minus 1, that I have written T minus 1. Then Newton, as you know, dimension formula of Newton. mlt minus 2 raised to minus 1. So here I've got the dimensional formula of student mobility, a m minus 1 t square. Now what is the use of this dimensional formula? You can find out on what factors mobility depends. See, what are the factors? I've written it in a box. Electric current in ampere terms. Ampere, no, electric current is dependent. Mass, it is dependent. Mass means mass of the charge carrier, m minus 1. And time also it is dependent, t raised to square. Okay. So you can easily find out how on what factor mobility depends. Now student, about the drift velocity. See, the velocity acquired by the electron or charge carriers due to the electric field. In the 11th class already you know the formula how velocity is found out, u plus at. I have written it on the screen, just see student. Acceleration is f upon m. Now initial velocity is 0. On that basis acceleration f upon m. So what is f? Force, and as you know force and a charge carrier is given by q into e from the first chapter. On that basis I have derived the formula for drift velocity, student. You write it in your notebook in a systematic way. First you write down the formula, basic formula. So here I have written on the screen, as you can see. So I have another formula for drift velocity, small e capital E, relaxation time upon m. Then another formula is derived from mobility. You can see, student. In video I have written that formula. E I have replaced it by q. So I got another formula of mobility, q tau upon m. What is tau, student? Relaxation time. And what is relaxation time? The average distance traveled between two successive collisions. As you know, electrons are continuously colliding. I have shown yesterday in the previous lecture, as in case of gas molecules, student. So I think now it is clear, student, about the mobility. You just frame it in your own mind, in your own sentence. You don't have to copy exactly what is written. Now, student, for positive charge. For positive charge, how will you write the mobility formula? See, I have written electron. See on the top. Sorry, student, it is for negative charge, not for positive charge. For positive charge, I have written it below. And I have written it as a positive charge is also known as holes. I have written the sign plus sign. Now you compare electron and holes positive charge. Whose mass is greater? As you know, mass of hole is much greater than electrons. Hence, the mobility of hole will be much less than electrons. As you know, electrons are free charge carriers. Now, student, let us compare the mobility of electrons as compared to hole in different substance. So, student, you can see the table on the screen. First, diamond. In diamond, how much is the mobility of the electron? It is 1800 coulomb meter square per volt per second. Mobility of hole 1200. Similarly, you can see, student, silicon I have written. How much is the mobility? 1350. Holes 480. Then I have written, student, gallium arsenide. It is semiconductor, student, and see its mobility 8000 and holes 300. You will learn in semiconductor, student. Again I will ask you about this. You will that gallium arsenide, it has a mobility of 8000. That is why it is used for making LEDs. You will learn it in much detail in there. So now can you differentiate, student, about the mobility of different substances and how it is affecting by the meaning of the word mobility, student? Now, student, I am coming to the one of the very important law, which is known as Ohm's law. But remember, student, Ohm's law only does not mean V proportional to I. You have to go in a minute detail. So let's start from that basic concept itself, which you already know. I have taken a conductor and applied a variable voltage it, and I've connected an ammeter also and a voltmeter. So this you already know that potential difference is proportional to current, but condition is temperature pressure should remain same. Then it is, student, then it is Ohm's law. And I have drawn just a observation table which comes in case of Ohm's law. Now, student, let's see the graph. Remember, there are two kinds of VI graph. In one, the V is taken along x-axis and I is taken along y-axis. In another case, I is taken along x-axis and V along y-axis. From this graph, if you find dV by dr, means you select 2 points in the graph, and in those 2 points check the change in voltage and the change in current and find the ratio. That will give you the resistance R. As I have drawn the graph on the screen, can you see it? I have named it first and second. So which one will have higher resistance in this? Just student, you check it on your own whether R2 is greater than R1 or not. Simply find the slope, the ratio dV by di. The simplest method is you take same voltage on both the graph. Same voltage you take, and then you find out the current related to that voltage in both the graph and find out dV by di. You will easily get which one is at higher resistance. But remember student, there are two kinds of graph. In one, V is taken along x-axis, in another, the V is taken along y-axis. In both the cases, you should see it very carefully while finding the resistance. In one case, the higher slope will give higher resistance. In second case, lesser slope will give higher resistance. It depends on which axis V is taken. This you already know it. Now student, let's come into the proof. Yesterday already I have derived current relation with drift velocity. NEAVD. What is small n? It is the number of electrons per unit volume in that substance, in that sample, in that metal which you have taken. E already you know it, electronic charge. A is the area of the sample taken, and Vd is the drift velocity acquired. Then I have replaced Vd with the formula just derived before, E capital E tau upon m. Now the formula is n small letter e square capital E tau upon m. All the terms I think you remember it. Tau is the relaxation time, E is the electric field, area A is the area of the cross section of the sample, m is the mass of the charge carrier. Remember student, m is the mass of the charge carrier. It is not the mass of the substance. E already you know it. Okay. Now then again we have a relation between electric field and potential difference that I have written V by L. Now you see the formula very carefully student. What formula we are getting? I is equal to small n, small e square, tau, capital A, V upon m into L. This is the formula which you are getting for the current. Now students see, E and m are constant because E is the charge of the electron, m is the mass of the electron. Remember student, m is the mass of the electron. Small n, number of charge carriers per unit volume. Remember, small n is a constant for a given substance, student, for a given substance. If I change the substance, small n will change. It is not a universal constant. But small e and m will remain same. Small e and small m mass will remain same. But n will change when I will change the substance. Suppose I am studying on aluminium. Then I replaced it with copper. For copper, this small n will change. So student, this is where you have to concentrate your mind, that which quantity will change on which factors. Now at constant temperature, relaxation time is constant student. If you're not changing the temperature, again I am making you remind that what happens with increasing temperature. See, with increasing temperature, the thermal velocity or the velocity will increase. Now when velocity increases, the number of collision will increase. So the relaxation time which electron is used to get, that will student definitely decrease. So if the temperature is constant, this relaxation time is constant. Now student, A and L, they are constant for a given sample. As just now I told, if I change the sample, say different, I am changing the different area of aluminium, I am taking the different length, so that it will change for a given sample. But if I take the same sample for studying, then this thing all are constant student. E and M, see again, small n, constant temperature, A and L. If I am not changing the sample, these quantities are all constant. Now student, you see the formula very carefully. I is equal to n e square tau capital A V by ml. All are constant except one quantity is remaining. And what is that quantity student? You can see it is potential difference. So now we are getting I is proportional to V, or V is proportional to I. This is the condition, and this is what student the Ohm's law is. I think now it is clear student. So now if I take the ratio V by L student, the formula which I am getting is, see it is on the screen. ml upon n e square. The discrete is tau. Okay, student, small e square, near it is tau, relaxation time upon into a, area of cross section. And student, this ratio is known as resistance R. Resistance is the property of the student material, property due to which there is a hindrance in the flow of charge carriers. Once again, student, I am signifying the importance, clarifying this formula, student. See, if we change the metal, if you change the substance, small n will change. See, I have written on the short in the screen also I have made. Which quantity will change due to change in sample? If I change the metal or change the sample, small n will change, student. If I change the sample, A and L will change. And if I change the temperature, student, temperature, tau will change. But charge and mass of the electron will not change. Once again written, I have written a short note about the thermal velocity, student. If we increase the temperature, thermal velocity increases, and when thermal velocity increases, the relaxation time will decrease. So this is how, student, you have to prove the Ohm's law, and this is actually derivation of Ohm's law on the basis of drift velocity, student. Drift, again remember it, drift velocity, the average velocity with which electrons are moving in a particular direction due to the effect of electric field, and this velocity is very less as compared to electric current, as compared to thermal velocity. This gives rise to electric current. This drift velocity of the electron makes the electric current, which is responsible for the all the other works which is done. So student, today we have discussed about the term mobility, about Ohm's law statement, about the proof of Ohm's law, student. So student, once again I will remind you, try to use your right part of the brain, the creative part. Just make a imaginary video file what we have studied, and then try to write on your own words. And this flow chart you should remember. First you talk about mobility, you try to write about mobility, what you have understood. As I have said, it is the drift velocity acquired per unit electric field. I have shown one table also of different mobility of different related to different substance. You can compare it, you can analyze it, its depth meaning. Diamond 1800 electron, you can write in detail what is the meaning of this 1800, because now you know the basic meaning of mobility. Silicon, it is 1350 electron. You can write in own words what this 1350 means. And remember, this unit is in centimeter, student, okay? The number which is written. Then you can write Ohm's law. What Ohm's law, under what condition it follows. For example, condition is temperature pressure must remain same. When V is proportional to I, that is a ohmic substance or ohmic conductor, which we say it. Then about the graph, then about the proof of the Ohm's law, which I have said, starts from the current formula, student, and ultimately we are able to derive the Ohm's law as you have written, and which quantity will change, which are universal constant. So hope, student, you have understood. If any doubt related to this video, you can ask it by calling me also or by writing it. Okay. The next I will do the topic of resistivity, the next part of this. Okay, student. Thank you.